All right, so solving systems by substitution, it's one of our methods for solving, using algebra. And it's definitely better than solving by graphing. Graphing gets difficult when your answer comes out to be, not an integer, so any kind of decimal fraction, whatever you want to say. So we're going to work on substitution first, and then elimination, and then when you got to use algebra to solve a system, like it comes down to how the equations are set up, whether you'd want to use substitution or elimination. All right, but both of them should result in the same answer, so it really doesn't matter what method you use. There's just advantages and disadvantages to both. So first up, when you're going to solve a system of equations by substitution, you want to have a variable already solved for. So y is solved for in both equations. So what we can do here is we're saying y equals x plus 3 and y equals 2x plus 5. This is like saying, I have a dollar bill is equal to 4 quarters. A dollar bill and 4 quarters, they look different, but they have the same value. So y and x plus 3 are the exact same value. So what I can do is I can substitute, let me just rewrite these. I can take this x plus 3 and put it in for y in that second equation, and now I have x plus 3 equals 2x plus 5. So now I just got to solve this equation. So I'm going to subtract 1x from both sides. I get 3 equals x plus 5. Subtract 5 from both sides, so I get negative 2 equals x. So that means x equals negative 2. But again, going back to what we were learning about with solving systems by graphing, all your solutions need to be an xy pair. So I'm going to put this negative 2 back into my first equation. You can use either equation here, just the first one seems easier. So y equals negative 2 plus 3, so y equals 1. So my solution is negative 2 comma 1. I would always just go back, if I put negative 2 in here, 2 times negative 2 is negative 4, negative 4 plus 5 is 1. So you're good. It works in both equations. But again, all answers are still going to be an xy pair. So this whole chapter, when we're working through this stuff, you should always get an xy pair for your solution. All right, so next up we got y equals 2x plus 7 and x equals negative 5. So we already solved for x here. X is equal to negative 5. So you just got to figure out y, which is 2 times x, negative 5, plus 7. So that means y equals negative 10 plus 7. So y equals negative 3 is what y equals. So that means your final answer is negative 5, comma, negative 3. All right, so next up, we're looking a little different here, okay? And the main thing we're looking for, like those first two are kind of pretty easy ones, but as we work through these substitutions, this is where we're going to start to really see in a problem that's kind of tailor-made for solving by substitution, okay? So the main thing we're looking for here is that in the second equation, we have x equals, and that's what we need. Okay, so what we can do here then, I just want to keep my original intact. I don't want to start marking it up. With this second equation with x equals 8y minus 12, that same analogy I used before where if you want to think of x as being a dollar bill, this is 4 quarters. If you're going to think of it as 2 half-dollar coins, whatever, because I only got 2 terms there. Whether you have a dollar bill or 4 quarters, that's the exact same amount of money. You go to a vending machine, you try to buy something, whether you got a dollar bill or 4 quarters, it doesn't matter. You still got a dollar. So I can take this 8y minus 12 and put it in for x in my first equation. Because again, you can't solve an equation up here with 2 variables. So all I'm doing is replacing x in my first equation with 8y minus 12. Now I have 8y minus 12 plus 12y equals 68. So 8y plus 12y, we're just solving an equation here. You want to combine like terms first. So 8y and 12y is 20y minus 12 equals 68. I'm going to add 12 to both sides. So 20y equals 80. Sorry about that. And then divide both sides by 20, and I get y equals 4. So once I get that y equals 4, I still need to figure out x. My second equation there was x equals 8y minus 12, so I can say that x equals 8 times 4 minus 12. So that means x equals 32 minus 12, so x equals 20. So make sure your answers are always x comma y. It gets tempting. It gets tempting because we solve for y first to maybe put the 4 first, but you always want to put x first, y second. All right, so another similar problem here where in this case I have y equals. It doesn't matter if you have y equals or x equals. It doesn't matter what variable you solve for first. You just want to figure out one of them so that you can solve for both. So again, it's that same theme of y is like having a dollar bill, x minus 4 is like having 4 quarters. They're the same value, just look different. But in this case, since y is equal to x minus 4, I'm going to put x minus 4 in for y in that first equation. And nothing in that first equation changes except for replacing the y. So I got 6x plus, I got to do some distributive property here, 3x minus 12 equals 15. 6x and 3x is 9x. Then I'm going to add 12 to both sides. So 9x equals 27. Divide both sides by 9. So we get x equals 3. So once we get x equals 3, my second equation was y equals x minus 4. So that means I get y equals 3 minus 4. So y equals negative 1. So final answer is going to be 3, negative 1. All right, so we get to one like this where we don't have x equals and we don't have y equals. So you have to do that yourself now. So you have really 4 options as far as what variable you're going to solve for here. You got this negative 5x, you got this y, you got this x, you got this negative 4y. You got to solve for one of them. It doesn't matter. You have 4 choices though. If you have one like this where x minus 4y equals 11, all you got to do is move the 4y to the other side and we'll have x equals 4y plus 11. So that's what I'm going to do here. I'm going to add 4y to the left, add 4y to the right, and get x equals 4y plus 11. So again, I can take this 4y plus 11, put that in for x in my first equation there. So that's going to be negative 5 times 4y plus 11 plus 4y equals 9. Again, when you're substituting, be very careful that All I'm doing here is replacing x with the 4y plus 11. Everything else stays intact. The negative 5, the plus 4y, and the 9. So I got to do some distributive property here. Negative 20y minus 55 plus 4y equals 9. Again, the negative 5 only gets distributed to the terms inside the parentheses. Combine your like terms here. So it's going to be negative 16y minus 55 equals 9. Add 55 to both sides. And then you're going to get y equals negative 4. So we got y equals negative 4. We solved for x up here. We said that x was equal to 4y plus 11. So that means x is equal to 4 times negative 4 plus 11. So x equals negative 16 plus 11. So that means x equals negative 5. All right, as always, if you want, you can go back and check your answers. You don't have to, but it's always a good idea. So if you go back in the first equation, you're going to have negative 5 times negative 5 plus 4 times negative 4, equals 9. So that's going to be 25 minus 16 equals 9. So you get 9 equals 9, so that's good. Second equation, you have x, so it's negative 5. Minus 4 times negative 4 equals 11. So we're going to have negative 5 plus 16 equals 11. Negative 5 plus 16 is 11. You get 11 equals 11. So everything works out. So you don't have to check your answer, but it's always a good idea to. All right, and then the last one, this is definitely the trickiest out of all of them. Most work. So in the first equation, we have 4x minus 8y equals 52. And the second equation, we have 6x plus 5y equals negative 7. So if you want to pause the video quick and copy that down, that'd probably be best. All right, but again, your decision here is which variable is going to be easiest to solve for. If I try to solve for x in my first equation, I would have to do 8 divided by 4, which is fine. That's 2. 52 divided by 4 is 14. Or 13, sorry. The second equation is just bad news, because if I try to solve for x, I'm going to have 5 divided by 6. I'm going to have to deal with 5/6 y when I'm working through this. If I try to solve for y, I'm going to have 6 divided by 5 and like 6/5. That's not good either. Even up here, 4 divided by 8 is not good. So I decided that I'm going to solve for x in the first equation just because 8 is divisible by 4 and 52 is divisible by 4. So I'm going to add 8y to both sides. And divide everything by 4, like I said. So this is going to be x equals 2y plus 13. And again, the whole goal here is, make it as easy as possible. So my new equation is going to be x equals 2y plus 13. Not new equation, but just, I solve for x, so it just looks a little different. Second equation stayed the same, 6x plus 5y equals negative 7. So I can take this 2y plus 13 and put it in for x in the second equation. So I got 6 times 2y plus 13 plus 5y equals negative 7. Distribute the 6. 12y and 5y is 17y plus 78 equals negative 7. Subtract 78 from both sides. I get 17y equals negative 85. So that means y equals negative 5. So once you get that y equals negative 5, we still know from before that x equals 2y, so that's 2 times negative 5 plus 13. So that means x equals negative 10 plus 13. So x equals 3. So final answer here is going to be 3 comma negative 5. Again, all answers should be in ordered pair. If you want to go back and check your answers, that's always a good idea. Go back to the originals. So we had 4x, so 4 times 3, minus 8 times negative 5 equals 52. So that's going to be 12 plus 40 is 52. So 52 equals 52. That's good stuff. Second equation then. You get 6 times 3 plus 5 times negative 5 equals negative 7. So it's going to be 18 minus 25 equals negative 7. 18 minus 25 is negative 7, so that all works out. So you can always check your answers to make sure you did everything correct. But just, the goal is to solve for one of those variables and then go from there. Have a good day.